Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you'd like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam IFM. You are given the following information about the annual returns of two stocks X and Y. The expected returns of X and Y are R sub X equal to 10% and R sub Y equal to 15%. The volatilities of the returns are V sub X equal to 18% and V sub Y equal to 20%. Now, volatility means the square root of the variance of the return, so it's a standard deviation. The correlation coefficient of the returns for these two stocks is 0.25. The expected return for a certain portfolio consisting only of stocks X and Y is 12%. Calculate the volatility of the portfolio return. So there is a certain portfolio of these two stocks X and Y. And let W stand for the fraction of the portfolio that we're considering invested in stock X, and then 1 minus W is the fraction of the portfolio invested in stock Y. So we have for the 0.12 is WRX plus 1 minus WRY, because the expected returns weighted average of the returns of the two securities. And that's 0.10 times W plus 0.15 times 1 minus W, and that's 0.15 minus 0.05 W, from which we see that 0.05 W has to be equal to 0.3, so that W has to be equal to 0.3 divided by, I'm sorry, 0.03. So 0.15 minus 0.12 is 0.03, divided by 0.05, so 3 divided by 5, which is 60% of 0.6. So W is 0.6, 1 minus W is 0.4. Now let us write U for the random return of stock X and V for the random return of stock Y. Then the volatility of the portfolio return is the variance of 0.6 U plus 0.4 V. And that's the square root of the of 0.36 of the variance of U plus 0.16, the square of 0.4, of variance of V, plus 2 times the weights, 0.6 times 0.4, times covariance of U and V, which is equal to the standard deviation. The covariance is equal to standard deviation of U times standard deviation of V times the correlation coefficient of the two. The correlation coefficient is given as 0.25, and the standard deviations of the returns of first and second security are given as 0.18 and 0.20 in the problem. So we just plug this all in. The variance of U is 0.18 squared, the variance of V is 0.20 squared, and then we have the 0.18 and 0.20, the standard deviations, plugged in, and then it's just calculation. It comes out to be about 0.1496, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.